Welcome back, everyone, to Concepts in Arithmetic. We are continuing our discussion of the various algorithms for the arithmetic operations. We have already worked on addition and subtraction, and what typically comes next in the teaching sequence is multiplication. In fact, this is kind of what has to come next in the teaching sequence. So the multiplication algorithm is typically started in second grade, and these are the four kind of things that are required of students before they can engage with the multiplication algorithm. They need to know their one-digit multiplication facts. They need to understand rebundling as used in the addition algorithm, so this is why it comes later in the teaching sequence. There are a couple of new features in the multiplication algorithm that aren't present in the addition and subtraction algorithms. In particular, shifting over place value when you're multiplying by 10 or a multiple of 10. That doesn't come up in the other algorithms, so we'll see that illustrated here. And also, we need to understand how the distributive property is working when we handle the multiplication algorithm. So this would be taught in stages, just like the other algorithm, proceeding from the simpler examples to the harder examples. Now, there's kind of a couple different levels to this. So stage one would be multiplying by one-digit numbers. But even within stage one, there are varied levels of difficulty. So let's do a stage one example that involves no rebundling. So what we're trying to find here, let's say we want to do, oh no, I don't want to do that. Let's do 21 times 3. Okay, so as with the other algorithms, we can start by illustrating things with the chip model. Okay, well, 21 times 3, let's think all the way back to the definition of multiplication as repeated addition. Okay, so let's consider this 3 groups of 21. Okay, so we can load 21 into the chip model 1, 2, 3 times. Okay, so we have 3 groups of 21. All right, and we can see here in the chip model, I mean, we get the answer right away, right? 6 tens, 3 ones, so 63. Now, typically, the standard algorithm is put like this. It's not put horizontally anymore. It's like this. Okay, so 3, 6. And you might say, well, this doesn't use the distributive property at all, but actually it does, right? It's right here. Right? So if I do 3 groups of 21, well, I have 3 groups of 20, which gives me 60, and then I have 3 groups of 1, which gives me 3. Okay, so in other words, 21 times 3 is 20 plus 1 times 3, which we would distribute 20 times 3, 1 times 3. Okay, so the distributive rule is there in the background. Okay, so this is a starting example which doesn't involve any rebundling. Let's go to a kind of second level example, still multiplying by a one-digit number. But this will involve rebundling. Okay, so in this example, what shall we do? Let's do 20. 28. Why not? 28 times 3. Okay. So we can start by illustrating with the chip model with tens and ones. So we're going to put in 3 groups of 28. So 2, 1, 2, 3, 4, 5, 6, 7, 8. That's one group of 28. 1, 2, 3, 4, 5, 6, 7, 8. There's our second group. And finally, our third group of 28. Okay, so let's look at what we have here. In the tens place, well, that's easy. We have 6 tens. Okay, so we're good there. Here is a bit of a problem here, right? We have 1, 2, 3, 4, 5, 6 groups of 4. We have 6 rows of 4. So we actually have 24 things in the ones place. Okay, so this is no good. We're going to need to trade some of these in here. Okay, well, there's a group of 10. I can take those and trade them in for a tens chip. I've still got too much though, right? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 chips left over. So what I'll do is I'll take another 10. And I'll trade those in for 1 over here. Okay, so here we had to, let's look at this. We'll do the standard pencil and paper algorithm. Now, kind of remember what we're going with here, right? We know our one-digit multiplication facts. 3 times 8 is 24. Okay, so we would have a 4 carry the 2. Okay, 2 times 3 is 6, plus the 2 that we're carrying over is 8. And look at how that is illustrated in the chip model. Okay, we started by loading in 3 copies of 28. And that left us with 1, 2, 3, 4, 5, 6 rows of 4. It left us with 24 chips in the ones place, because 3 times 8 is 24. Okay, so we traded in 2 groups of 10. We got 2 more chips in the tens place. Okay, and this is a good problem for illustrating why this 2 is added after we multiply. Okay, we do 3 times 2, and then we add the 2 from the rebundling. Okay, and of course, we can see that distributive rule sitting in that background there. 28 times 3 is 20 times 3, which is 60, plus 8 times 3, which is 24. So we would have 60 plus 24, and look at what we're getting right there, 84. Okay? So, we've got this first stage for the multiplication algorithm, and that's multiplying by one-digit numbers. And now we can start a transition to the second stage of the multiplication algorithm, which would be multiplying by multiples of 10. Okay, now I've got primary math 3A right here, and I am looking at page 49. Okay, so that's a one-digit multiplication problem, very easy. Okay, so 4 times 3 is 12. 40 times 3, it's actually not much harder, right? Because we'd have 3 groups of 40, which we could illustrate with 4 value 10 chips. So we have 12 groups of 10s, right? 4 tens times 3 is 12 tens. Well, 12 tens is 120, right? We could cash in one of those and rebundle there. Okay, and then we've got this illustration right here, 400 times 3. Okay, so in the bottom here, this illustrates how that would look in the standard algorithm. 4 times 3 is 12. 12 tens. Okay, so notice there's that shift. Here we're doing 4 times 3, but we have this extra multiple of 10 that shifts over one place value. And over here we have shifted over two place values. Okay, so dealing with multiples of 10 leads us to the transition to stage 2, which is multiplying by two-digit numbers.